Welcome to the class, students. In this class, I am going to solve some polynomial equations. Okay. In previous class, we learned how the method of synthetic division, Horner's method of synthetic division. So that we learned in the previous class. Now I am going to solve some problems, some polynomial equations. That is, solving of a polynomial equation means to find the roots of the polynomial, given polynomial equation. Okay. So there are several methods to find the roots of the given polynomial equation depending on the nature of the equation. So, depending on the hypothesis of the problem, we adopt different methods to solve the problem. So, here, observe some examples I am doing here. Observe this problem, that is, find the roots of the equation. So, see here, the equation is x power 4 minus 16x cube plus 86x squared minus 176x plus 105 is equal to 0. Okay. So this is biquadratic equation. At most it has 4 roots. They may be repeated roots or they may be distinct roots. So that we can see. See here. Let f of x first of all, this polynomial ఏదైతే ఉన్నదో polynomial observe. First of all of you are aware of polynomial equation and polynomial. Polynomial means this fx, this is polynomial. If you write fx is equal to 0, this is the polynomial equation. Okay. So ఈ polynomial ని fx గా అజ్యూమ్ చేసుకున్న తర్వాత let fx is equal to given polynomial రాసాను. దీని ఏమన్నాము in previous class we discussed, that is a trial and error method. Trial and error method. Okay. Trial and error method means by inspection we find a root of the given polynomial equation. ఎలా అంటే ఇక్కడ చూడండి, by inspection ఎలా రాసాను, by inspection f of 1 is equal to, అంటే ఈ polynomial లో x is equal to 1, 2, 3, minus 1, minus 2, minus 3, minus 4 ఇలా చెక్ చేయడం ద్వారా, అంటే 1 is equal to x equal to 1 సబ్స్టిట్యూట్ చేసినప్పుడు మనకి f of 1 వస్తుందండి. ఇది 0 అయితే అర్థం ఏంటి, x is equal to 1 is a root, is a solution of the given polynomial equation అని అర్థం అని తెలుస్తుంది. సో ఒకవేళ 1 పెట్టినప్పుడు f of 1 0 కాలేదనుకోండి, అప్పుడు we go for 2, x equal to 2, అలా నెక్స్ట్ 3, ఇలా దీన్ని ట్రయల్ అండ్ ఎర్రర్ మెథడ్ అంటారు. బై ఇన్స్పెక్టింగ్, ఓకేనా, ఈ విధంగా చూసి బై ఇన్స్పెక్షన్ అంటే x ఈక్వల్ టు 1 పెట్టినప్పుడు f of 1 ఇలా వస్తుందండి. అప్పుడు ఇది 192 minus 192 we got 0. సో f of 1 is equal to 0 అయిపోయింది కాబట్టి x is equal to 1 రూట్ అవుతుంది. అండ్ అకార్డింగ్లీ x minus 1 is a factor of f of x. Basing on the remainder theorem, if f of x minus a is a factor of f of x, if and only if f of a is equal to 0, that you will learn in the 10th class itself. Okay, f of 1 is equal to 0 అయిపోయింది కాబట్టి x minus 1 is a factor of f of x. ఈ x minus 1 fx కి x minus 1 ఫ్యాక్టర్ అయింది కాబట్టి మరి ఫ్యాక్టర్ అంటే కోషెంట్ ఏమొస్తుందో తెలియాలి. ఆ రిమైండర్ 0 అయితే ఫ్యాక్టర్ అవుతుంది. కోషెంట్ కోసం ఏం చేస్తున్నానంటే, ఓకే, కోషెంట్ కోసం ఏం చేస్తున్నాము, డివైడ్ fx by x minus 1 using Horner's method of synthetic division. So Horner's synthetic division యూజ్ చేసే in previous class లో చెప్పాను కదా. సో దాన్ని సింథటిక్ డివిజన్ బేస్ చేసి తీసుకొని ఈ fx ని అంటే దీన్ని x minus 1 చే డివైడ్ చేస్తాము. See here the method once again I explain here. So చూడండి, first of all you have to write all the coefficients in a row like this రాసాను. నెక్స్ట్ ఇక్కడ x మైనస్ ఏ అంటే ఇక్కడ ఏ తీసుకోండి, ఇక్కడ x మైనస్ 1 కాబట్టి 1 తీసుకోవాలి. ఒకవేళ ఇక్కడ x ప్లస్ 1 వచ్చింది అనుకోండి, అప్పుడు ఇక్కడ మైనస్ 1 రాసుకొని ఇక్కడ మైనస్ 1 రాయాల్సి ఉంది. ఓకే. So I am going to put 0 here and 1 add and multiply 1. So this is add changing minus 15 into 1 minus 15 and add 71 ones are 71 and again add minus 105 and again multiply. So minus 105 into 1 minus 105 and add just the zeros. So this is the remainder, okay now? And this is the quotients of the quotient. So that's why ఏం రాస్తాం ఇప్పుడు fx is equal to fx ని దేంతో డివైడ్ చేసాము x minus 1 తో డివైడ్ చేసాము కాబట్టి fx therefore fx is equal to x minus 1 into quotient డివైడ్ చేయగా వచ్చేటువంటి quotient అంటే ఇక్కడ చూడండి x minus 1 తో డివైడ్ చేసాం కాబట్టి మన పాలినామియల్ డిగ్రీ ఒకటి లెస్ చేసి రాసుకుంటూ రావాలి 1 into x cube minus 15 into x square plus 71x minus 105 చూడండి 1 into x cube minus 15x square plus 71x minus 105 this is the quotient this remainder is 0 okay so ఇది ఫ్యాక్టర్ కాబట్టి ఇంకో ఫ్యాక్టర్ ఎలా వస్తుంది డివైడ్ చేస్తే వస్తుంది ఇప్పుడు ఫర్ ఎగ్జాంపుల్ 6 ఉన్నదండి దీనికి 2 ఫ్యాక్టర్ అని చెప్పాను 2 ఫ్యాక్టర్ అయినప్పుడు 2 3s are 6 అని వస్తుంది ఇప్పుడు 6 ని ఏం రాస్తాము 2 into 3 గా రాస్తాము ఎందుకు ఈ 2 ఫ్యాక్టర్ అయినప్పుడు అదర్ ఫ్యాక్టర్ ఏంటో తెలియాలంటే డివైడ్ చేయాలి అర్థమైందా సో 2 ఫ్యాక్టర్ అని తెలుసు మరి 6 is equal to 2 into what 2 3s are 6 okay like that so in order to get this quotient we divide like this okay ఇలా వచ్చిందండి ఇప్పుడు దీన్ని కూడా ఫ్యాక్టరైజ్ చేయాలి దీన్ని ఇది క్యూబిక్ ఎక్స్ప్రెషన్ క్యూబిక్ పాలినామియల్ ఇది దీన్ని మళ్ళీ మనం ఫ్యాక్టరైజ్ చేయాలి అంటే అగైన్ క్యూబిక్ ఎక్స్ప్రెషన్ ఇది gx దీన్ని gx గా అజ్యూమ్ చేసుకున్నాను let gx is equal to this one by inspection okay by inspection g of 3 is equal to అంటే ఇక్కడ gx ఉన్నది gx లో మళ్ళీ అగైన్ అక్కడ చేసినట్టుగానే ఇన్స్పెక్షన్ మెథడ్ లో చేస్తున్నాను g of 1 if you check g of 1 so it is not equal to 0 and again g of 2 and now g of 3 అవి నేను ఇక్కడ చేయలేదు కావాలంటే మీరు పక్కన చేసుకోండి g of 1 0 కాదండి అలాగే g of 2 కూడా 0 కాదు g of 3 పెట్టినప్పుడు ఇలా వచ్చేసి 240 minus 240 we got a 0 okay so that's why ఈ g of 3 is equal to 0 వచ్చింది కాబట్టి x minus 3 is a factor of g of x ఇక్కడ చూడండి ఇక్కడ 1 పెట్టినప్పుడు 0 f of 1 0 అయింది కాబట్టి x minus 1 is a factor of f of x again similarly ఇక్కడ g of x ఉంది g of 3 0 అయింది కాబట్టి x minus 3 is a factor of g of x okay x minus 3 is a factor of g of x okay ఈ ఫ్యాక్టర్ అన్నప్పుడు ఇందాక చెప్పినట్టుగా ఇంకో ఫ్యాక్టర్ ఏదో తెలియాలంటే ఏం చేయాలి డివైడ్ చేయాలి now we divide g of x by x minus 3 using Harness method of synthetic division so కాబట్టి అగైన్ మళ్ళీ g of x కోషంట్స్ ఏవైతే ఉన్నాయో అవి రోలో రాసుకోవాలి ఇక్కడ 3 x minus 3 అంటే x minus a అంటే a plus ఉంది 3 ఉంది 3 తో డివైడ్ చేస్తున్నాము ఈ మామూలుగా ఇక్కడ 0 పెట్టండి 1 3s are 1 ఇలా చేశాను ఓకే ఇక్కడ చూడండి minus 12 into 3 minus 36 add చేసి 35 3s are 105 and add చేసి the remainder is 0 so now what you write okay now I continue see here okay now so ఇప్పుడు g of x now g of x therefore g of x is equal to x minus 3 into x minus 3 తో డివైడ్ చేస్తే వస్తుంది కోషంట్ సో ఇక్కడ చూడండి x minus 3 g of x అంటే క్యూబిక్ ఎక్స్ప్రెషన్ దీన్ని ఒక డిగ్రీ తగ్గించి రాసుకోవాలి 1 into x square minus 12 into x plus 35 ఓకే ఇది g of x సో దీన్ని ఇది quadratic expression we can easily factorize this minus 35. So factorize x common this x minus 7 minus 5 x minus 7. Okay, go for it. మీరు కావాలంటే పక్కన చేసుకోవచ్చు ఫ్యాక్టరైజేషన్. సో చేస్తున్నాను. x minus 7 కామన్ తీసేస్తే x minus 5. This is g of x. So give this is number. Okay. From 1 and 2 we get 1 and ఇక్కడ నెంబర్ ఇచ్చాను చూడండి. fx is equal to ఇది 1 అండి. fx is equal to x minus 1 into what is this gx. So that is we get fx is equal to x minus 1 into gx. ఇది gx గా అజ్యూమ్ చేసుకున్నాం. So what is our gx? Our gx is equal to number 2 gx is equal to x minus 3 x minus 7 x minus 5. Okay, so fx ను ఇలా ఫ్యాక్టరైజేషన్ చేశారు. ఓకే, సో therefore మనకు రూట్స్ వస్తాయి. మీరు డోంట్ ఫర్గెట్. సో again I am repeating that fx is equal to, if you write fx is in the form of x minus alpha 1 x minus alpha 2 x minus and so on alpha 3 and so on x minus alpha. If your polynomial is expressed in this form, then alpha 1 alpha 2 alpha 3 and so on alpha n are the roots of the polynomial equation. Fx is equal to 0. Okay, so that's why hence ఎప్పుడైతే ఈ పాలినామియల్ ఎఫెక్ట్స్ ని మొత్తం x మైనస్ ఆల్ఫా 1 ఇంటూ x మైనస్ ఆల్ఫా 2 ఇంటూ x మైనస్ ఆల్ఫా 3 ఈ విధంగా ఫ్యాక్టరైజేషన్ పాసిబుల్ అవుతుందో అప్పుడు మనకి రూట్స్ అన్ని వచ్చేసినట్టు లెక్క. హెన్స్ the roots of the equation fx is equal to 0 or 1 3 5 7. The roots of the equation fx equal to 0 or 1 3 5 7. Okay, 1 alpha 1 alpha 2 alpha 3 alpha. So the given polynomial equation is of degree 4. That's why we got four distinct real roots. Okay, of course sometimes the roots may repeat. That means 3 3 3 5 7 like that. So then that root is called a repeated root or multiple root. Okay, so suppose ఇక్కడ x minus 1 ఇక్కడ కూడా x minus 1 వచ్చింది అనుకోండి, అప్పుడు this will become x minus 1 whole square and the root 1 is called a multiple root or a repeated root. Okay, so follow the problem. So this is the thing. Next I will come to the next problem. Okay. I come to the next problem. Solve the polynomial equation. Solve the equation x cube minus 7x square plus 36 is equal to 0. Given that 1 root being the twice of the equation. So observe the problem. Solve the equation x cube minus 7x square plus 36 equal to 0. Given that one root being twice the other. Given that one root being twice the solution. So observe. So here problems are and that means depending upon the hypothesis, and that is one root being the twice of the other. So that means a relation between the roots, is given. Then we have to solve the equation. And one root being twice the other, one root is opposite to that of other root. The sum of two roots is 0. A sort of a type of relation is relation between two roots is given. Then we have to solve the problem. These are one type of problems given in the textbook. So depending upon the nature of the hypothesis and the roots madhya relation ichcharu దాన్ని అడాప్ట్ చేసి మనం చేసుకుంటూ వస్తాము. See the problem. Given equation is, so what happened, see here in the earlier problem, the problem is the equation is biquadratic equation, and it is sometimes it is a difficult task to find a root of the given polynomial equation by using inspection method. Okay, so sometimes 1, 2, 3 it is not possible to find a root of a given polynomial equation by using inspection method. So that's why in that, if that is the situation, so there is if a relation between the two roots is given like this, then it is very easy to find the roots of the given polynomial equation. Okay, see here. Given equation is this one. Let alpha, beta and gamma be the roots of the equation. Okay, దీనికి roots alpha, beta, gamma and cubic equation కాబట్టి 3 roots ఉంటాయి. 3 roots alpha, beta, gamma గా అస్యూమ్ చేసుకున్నాను. ఓకే, చేసుకున్న తర్వాత ఈ 3 roots మనం కనుక్కోవాల్సి ఉంటుంది. Okay, now I wanted to write the relations between. So relations. Now the relations between roots and quotients. The relations are చెప్పండి. What is the first one? S1 is equal to minus P1. S1 అంటే sum of all roots. Minus P1. This is P1. Okay, 7 minus of minus 7. Okay. Next. S2 alpha beta plus beta gamma plus gamma alpha. S2 is equal to P2. So P2 అంటే ఏంటి? ఇక్కడ x కోషెంట్, x స్క్వేర్ అయిన తర్వాత x టర్మ్ వస్తుంది. x టర్మ్ లేదు ఇక్కడ, సో కాబట్టి 0. నెక్స్ట్ S3 alpha beta. S3 is equal to minus P3. అంటే మైనస్ ఇది P3 మైనస్ P3 అంటే minus 36. ఓకేనా? This is S1 is equal to minus P1, S2 is equal to P2, S3 is equal to minus P3. వీటి ద్వారా నాకు ఈ 3 ఈక్వేషన్స్ వచ్చాయి. ఓకేనా? So using these relations, and now I use the given condition, the given relation, one root being the twice of the other. So okay, since one root is the twice of the other, since one root is the twice of the other, Okay, let beta is equal to 2 alpha. 1 root ante beta is a twice of the other. Okay, beta is equal to 2 alpha. That means 1 root is a twice of the other. ఇలా తీసుకున్నాం. ఓకేనా, వెరీ సింపుల్. ఇప్పుడు ఈ రిలేషన్స్ ఏవైతే ఉన్నాయో వాటిలో now the relations are now the above relations become ఈ పైన రాసినటువంటి రిలేషన్స్ ఎలా అవుతాయి? బీటా ఉన్న చోటంతా కూడా మీరు 2 ఆల్ఫా సబ్స్టిట్యూట్ చేయండి. బీటా ఇక్కడ 2 ఆల్ఫా సబ్స్టిట్యూట్ చేస్తే ఆల్ఫా ప్లస్ సో ఫస్ట్ ఆల్ఫా ప్లస్ 2 ఆల్ఫా ప్లస్ గామా ఈజ్ ఈక్వల్ టు దట్ ఈస్ 7. ఓకే, దిస్ ఇంప్లైస్ ఆల్ఫా ప్లస్ 2 ఆల్ఫా 3 ఆల్ఫా ప్లస్ గామా ఈజ్ ఈక్వల్ టు 7. దీనికి 1 ఇచ్చుకోండి, నెంబర్ 1 ఇచ్చాము. ఓకే, సెకండ్ రిలేషన్. సో వాట్ ఈస్ ద సెకండ్ రిలేషన్? ఆల్ఫా బీటా. సో బీటా అంటే 2 ఆల్ఫా ప్లస్ 2 ఆల్ఫా గామా ప్లస్ గామా ఆల్ఫా ఈజ్ ఈక్వల్ టు 0. దిస్ ఇంప్లైస్ 2 ఆల్ఫా స్క్వేర్ 2 ఆల్ఫా గామా ప్లస్ ఆల్ఫా గామా అంటే 3 ఆల్ఫా గామా ఈజ్ ఈక్వల్ టు 0. So this is second one. Okay, ఇంకా third relation alpha beta అంటే 2 alpha gamma is equal to -36. This implies 2 alpha square gamma is equal to -36. Okay, this is third. సో ఈ 1 2 3 రిలేషన్స్ ఇప్పుడు రాసిన వీటిని సాల్వ్ చేసి మనం ఆల్ఫా బీటా గామా కనుక్కోవచ్చు. ఓకే, ఎలా ఫైండ్ అవుట్ చేస్తాం? సి హియర్, దీని నుంచి ఇక్కడ దట్ ఈస్ గామా ఈజ్ ఈక్వల్ టు 7 minus 3 ఆల్ఫా. ఫ్రమ్ 1 and 2 we get లేదా by solving 1 and 2 equations we get ఈ 2 లో 2 ఆల్ఫా స్క్వేర్ ప్లస్ 3 ఆల్ఫా గామా is 7 minus 3 alpha. 7 minus 3 alpha is equal to 0. Okay, so we eliminate gamma from 1 and 2. ఇక్కడ gamma is equal to 7 minus 3 alpha తీసుకున్నాం. ఇక్కడ గామా ఉన్న చోట 7 minus 3 alpha సబ్స్టిట్యూట్ చేసాం. 2 alpha square plus 21 alpha minus 9 alpha square is equal to 0. 2 alpha square minus 9, that means minus 7 alpha square plus 21 alpha is equal to 0. This implies minus 7 alpha common తీసేస్తే so alpha minus 3 is equal to 0. Okay, this implies alpha minus 7 and 12 వెళ్ళిపోతుందండి. That means alpha is equal to 0 or alpha is equal to 3. Alpha is equal to 0, alpha is equal to 3. So what is alpha? Alpha is the root of the given equation. So alpha is alpha 0 పెట్టండి ఇక్కడ 0 minus 7 0. So 0 minus 0 plus 36 equal to 0. So it is not satisfying. That is alpha is equal to 0 is not a solution of the given polynomial equation. Okay, if you check alpha is equal to 3, if you substitute the 3 here, so it will be satisfied. Okay, no? So okay, since alpha is equal to 0 does not satisfy the equation, satisfy the given equation. Okay, since alpha equal to 0 does not satisfy the given equation, alpha is equal to 3. Okay, alpha is equal to 3. So alpha 3 by the, what is beta? ఈ relationship beta is equal to 2 into 3, 6 వస్తుంది. సో 6 బీటా కూడా వచ్చేస్తుంది. ఇంకా గామా కావాలంటే ఇక్కడ సబ్స్టిట్యూట్ చేయండి. ఓకే, నేను రాస్తాను. ఓకే, ఆల్ఫా వచ్చేసిందండి. Now beta is equal to 2 alpha, that is equal to 2 into 3, 6. From equation number 1, gamma is equal to 7 minus 3 alpha, that is 7 minus 3, alpha is 3, 7 minus 9, that is minus 2. Okay, now hence the roots are, what are the roots? Alpha, beta, gamma. Okay, na? So alpha is 3, beta is 6, gamma is minus 2. Okay, so this is our problem. Okay. So when the relation between the roots, okay, when the relation, a relation between the roots is given, using that relation we can find all the roots of the given polynomial equation easily. So just now I solved this problem. See everything what I have did. So first of all you have to write all the relations between the roots and quotients, and then implement the condition whatever it is given in the problem. So here the condition is one root is twice of the other, that means I assume beta is equal to 2 alpha, and implement that condition in the relations. Show that by solving these equations we get alpha, beta and gamma. That is our solution. Okay, na? So we come to the next problem here. So come to the next problem. Okay. So what is the problem? I will see. Given that problem, given that two roots of the equation, 4x cubed this is the equation. Okay, this plus 6. Okay, given that two roots of the equation are equal, find all roots of the equation. Okay, this is our problem. So observe our given polynomial equation is a cubic polynomial equation. So they have given a relation. What is the relation? Two roots of the equation are equal. Find all roots of the equation. Find all roots of the equation. Two roots equal. Find all roots of the given equation. Okay. We will solve like this. Let what is given equation fx equal to 0. దీని ఎప్పుడు కూడా fx గా తీసుకోవాలి. Let fx is equal to 4x cube plus 20x square minus 23x. Okay, minus 23x plus 6. Okay, let fx is equal to this one. దీనికి ఆల్ఫా బీటా గామా ఓకే ఏం చేస్తాం లెట్ ఆల్ఫా ఏమైనా 2 రూట్స్ ఆర్ ఈక్వల్ ఒకేసారి మనం తీసుకోవచ్చు లేదా సరే ఒకేసారి అజ్యూమ్ చేసుకుంటాం ఎలా అంటే చూడండి 2 రూట్స్ ఆఫ్ ది ఈక్వేషన్ ఆర్ ఈక్వల్ దట్స్ వై ఐ టేక్ 2 రూట్స్ ఆర్ ఈక్వల్ ఆల్ఫా ఆల్ఫా బీటా ఈజ్ ఇట్ ఓకే వెరీ సింపుల్ సో ఓకేనా బిఫోర్ దట్ ఎఫ్ఎక్స్ ఇలా తీసుకునే ముందు మనం రూట్స్ రాయాలి అంటే ఫస్ట్ ఆఫ్ ఆల్ see here your polynomial equation should be a monic polynomial equation before you are writing the relations between roots and quotients. That's why see here what I am doing here given equation is 4x cubed plus 20x square minus 23x plus 6 is equal to 0. Okay, this is your polynomial equation. This implies divide by 4 on both sides. Why? So you have to make it as a monic polynomial equation. So x cubed plus by 4 change ఏమొస్తుంది 5x square minus 23 by 4x plus 6 by 4 is equal to 0. So this is your polynomial equation. Okay, given polynomial equation తీసుకున్నాం. So there is I think there is nothing wrong by dividing 4 on both sides. Okay, here now p1 p2 p3 are clearly visible. Okay, ఇప్పుడు ఏం చెప్పారు 2 రూట్స్ ఈక్వల్ అన్నారు కాబట్టి let alpha and beta. So here alpha can also be called as repeated root. Okay, beta let alpha beta gamma be the roots of the equation. Okay, directly on this. So now relations. Now first one ఏంటి s1 is equal to minus p1. This implies s1 is equal to s1 అంటే sum of all roots రాద్దామా alpha plus beta is equal to s1 is equal to minus p1. This is p1 minus p1 అంటే minus 5. So it is a very easy concept, don't get confused. And if you observe the previous classes, it is very easy to write all these things. 2 alpha plus beta is equal to minus 5. This is 1. Okay. Next, second one. What is second relation? S2 is equal to P2. This implies what is your S2? S2 దీనికి alpha beta plus beta gamma plus gamma alpha. చెప్పండి. Alpha into alpha beta plus beta gamma plus gamma alpha. So దీని beta మీరు మీ కన్ఫ్యూజన్ అయితే ఇలా రాసుకోండి alpha beta plus beta gamma plus gamma alpha. ఓకేనా? సో దట్ ఈస్ alpha beta అంటే beta ని alpha ఇక్కడ రాసాను beta కూడా alpha గానే అనుకున్నాను because two roots are equal. So now alpha beta అంటే alpha into alpha, beta gamma alpha into beta, మళ్ళీ gamma alpha beta into alpha. Okay, very simple. S2 is equal to our P2 is minus 23 by 4. So this implies alpha square, alpha beta plus alpha beta, 2 alpha beta is equal to minus 23 by 4. Okay. Okay. So we can write third relation also. Okay. So I write third relation. S3 is equal to minus P3. This implies what is your S3? S3 means alpha beta gamma, that is alpha beta is equal to minus P3 minus 6 by 4. This is P1, P2, P3. This implies alpha square beta is equal to minus 3 by 2. Okay, so we don't make it 3 each goes, we don't need this also. Okay, from 1 and 2, I call this as 2. By solving one and 2, this is one and 2 equations. We get 2 alpha. We get, see here, alpha square. Equation with alpha square plus 2 alpha. What is beta? Beta eliminate change. Beta is equal to minus 5 minus 2 alpha. Minus 5 minus 2 alpha. Beta is equal to minus 5 minus 2 alpha. So 2 alpha beta is equal to minus 23 by 4. Minus 23 by 4. Okay. This implies alpha square minus 10 alpha minus 4 alpha square is equal to minus 23 by 4. This implies alpha square minus 4 alpha square minus 3 alpha square minus 10 alpha is equal to minus 23 by 4. So minus common తీసి cancel out చేయండి. 4 into తీసుకొస్తే 4 into 3 alpha square plus 10 alpha is equal to minus 23. This implies 12 alpha square plus 40 alpha is equal to, so that is the 23 to this question, minus 23 is equal to 0. Minus 23 is equal to 0. Okay. Okay, we got a polynomial equation like that is a quadratic equation in alpha, that is we'll see go for factorization. That is plus 46 minus 6. లేదా if you want a factorization ఇలా రాలేదనుకోండి, so it is quadratic equation. So go for roots to find the roots of this equation. Alpha is equal to minus b plus r minus root of b square minus 4ac by 2a. So you got the factorization 46 alpha minus 6 alpha plus 40 alpha. Okay. 46 into 6 minus 6 you got సరిపోతున్నది. సో నేను ఫ్యాక్టరైజేషన్ ఇక్కడ చేస్తున్నాను. See here, two roots are equal అన్నారు కాబట్టి I assume alpha, beta కూడా ఆల్ఫాగానే తీసుకున్నాను. అండ్ థర్డ్ రూట్ ఈ రెండు రూట్స్ థర్డ్ రూట్ ని బీటాగా తీసుకున్నాను. ఓకేనా? అండ్ రైట్ ఆల్ ది రిలేషన్స్ లైక్ దిస్. అండ్ ఈ 1 and 2 రిలేషన్స్ తీసుకొని ఇక్కడ సాల్వ్ చేశాను. చేస్తే we got a quadratic equation in alpha like this, and I am going for factorization. This implies 12 alpha square. 12 alpha square. What is the common factor? 2 alpha. 2 alpha. 6 alpha. Okay na? Plus 23 minus 1. 6 alpha plus 23 is equal to 0. This implies 6 alpha plus 23 into 2 alpha minus 1 equal to 0. This implies, okay no, alpha is equal to minus 23 by 6 or alpha is equal to 1 by 2. Okay? By checking, ఇప్పుడు ఆల్ఫాకి రెండు వాల్యూస్ వచ్చాయి. సో ఓకే, we have to verify that which alpha satisfies our given polynomial equation. given polynomial equation ఇదండి, ఇది కానీ ఇక్కడ తీసుకొని ఆల్ఫా ని సబ్స్టిట్యూట్ చేస్తే ఏది సరిపోతే ఏది సాటిస్ఫై చేస్తే అది రూట్గా తీసుకుంటాం. ఓకేనా? Alpha is equal to minus 23 by 6 does not satisfy the given equation. Okay. Since alpha is equal to 1 by 2. Alpha is equal to 1 by 2. ఇంకా బీటా కావాలి అంటే ఇక్కడ -5 -2 ఇందులో సబ్స్టిట్యూట్ చేస్తే బీటా వస్తుంది. ఓకే, మనకి వాట్ ఆర్ ద రూట్స్? ఆల్ఫా అండ్ బీటా. సో ఫ్రమ్ 1 బీటా is equal to that is -5 -2 alpha. This is -5 minus what is 2 alpha? 2 into alpha. Alpha is 1 by 2. So -5 -1 -6. Okay. So we got all the roots. Hence, what are the roots? Hence, the roots are, what are the roots? Alpha ante alpha is 1 by 2, and the second root is also alpha. That is alpha 1 by 2, and beta is -6. Beta is -6. These are the roots. Okay. These are the roots. 1 by 2 -6 are the roots of the given equation. ఏం చేసాము? 2 roots are equal అన్నప్పుడు ఆ రూట్స్ 3 క్యూబిక్ పాలినామియల్ ఈక్వేషన్కి ఎన్ని ఉంటాయి? 3 ఉంటాయి. మూడింట్లో 2 రూట్స్ ఆల్ఫా తీసుకున్నాం అండ్ అదర్ బీటా. సో అండ్ రైటింగ్ ఆల్ ది రిలేషన్స్ బిట్వీన్ రూట్స్ అండ్ కోఎఫిషియంట్స్ అండ్ సాల్వింగ్ ద ఈక్వేషన్స్ 1 and 2. ఈ 3 ఇలాగే ఉంటుంది, బట్ 3 ఈజ్ ఆఫ్ నో యూజ్. దాన్ని అలాగే ఏం చేశాను, we get సాల్వ్ చేసి here we got a quadratic equation in alpha and solving. మీకు ఇలాంటి ఫ్యాక్టరైజేషన్ రాకపోతే సో గో ఫర్ ఫార్ములా బేసిక్గా చేసుకుని ఆల్ఫా వాల్యూ కనుక్కోవచ్చు. దట్ ఈస్ -b ప్లస్ ఆర్ మైనస్ √b² -4ac చేసుకోవచ్చు. ఓకేనా? సో దెన్ ఆల్సో యూ గాట్ 2 వాల్యూస్ లైక్ దిస్. ఈ రెండిట్లో ఏ వాల్యూ అయితే మనకి గివెన్ ఈక్వేషన్ సాటిస్ఫై చేస్తుందో ఆ ఆల్ఫా వాల్యూ తీసుకోవాలి. ఆల్ఫా ఇస్ ఈక్వల్ టు 1 by 2. ఓకే, ఆల్ఫా వాల్యూ ఇక్కడ సబ్స్టిట్యూట్ beta square. So this is our problem here. I come to the next problem. Okay. Okay. Problem. Solve the equation. Solve the equation. What is the equation? 4 minus 24 minus 24. Okay, this is the polynomial equation. 23 plus 18. Solve the equation. Given that the roots are in AP or in arithmetic progression. Here AP means not stands for Andhra Pradesh, so AP means arithmetic progression. Okay. See here. Solve the equation given that the roots are in AP arithmetic progression. Okay. If the roots are in arithmetic progression, అని చెప్పి ఇచ్చిన హింట్ మనకి ఒక రిలేషన్ ఇస్తున్నారండి. ఆ రిలేషన్ రూట్స్ ఎలా ఉంటాయంటే ఏపీలో ఉంటాయి, అర్థమెటిక్ ప్రోగ్రెషన్లో ఉంటాయని చిన్న క్లూ ఇస్తున్నారు, ఒక చిన్న రిలేషన్. సో అప్పుడు దీని ఈక్వేషన్ని సాల్వ్ చేయమన్నారు. 3 రూట్స్ నేను ఇందాకే చెప్పాను. సో సాల్వింగ్ ఏ హయ్యర్ డిగ్రీ పాలినామియల్ ఈక్వేషన్స్ is a tough job. So by inspection sometimes always it is not possible. So that's why if we have a relation between the roots, that means the roots are equal or the sum of 2 roots is 0 or something else. Here given roots are in AP ila chinnappudu unnappudu we can solve easily. Okay. So now I am solving here. Given equation is సో ఎప్పుడు కూడా మనం రిలేషన్స్ రాయాలి అని అనుకున్నప్పుడు ఎప్పుడు దీన్ని మోనిక్ పాలినామియల్ ఈక్వేషన్గా తయారు చేసుకోవాలి. డివైడ్ బై 4 ఆన్ బోత్ సైడ్స్. సో x³ minus 6x² plus 23/4x plus 18/4. This is polynomial. So now it is very clear. P1, P2, P3. Okay. సో మనకి ఇక్కడ రూట్స్ ఏమి ఇచ్చారు అని ఏపీ అన్నారు. ఏపీ అన్నప్పుడు ఏపీలో ఒక ఏపీ తీసుకున్నప్పుడు ఏపీలో టర్మ్స్ ఎలా ఉంటాయి చెప్పండి. ఏ ప్లస్ డి, ఏ ప్లస్ 2d ఇలా ఏ ప్లస్ 3d ఇలా ఏపీలో ఉంటాయండి. సో అయితే నేను ఇక్కడ ఫర్ ది సేక్ ఆఫ్ కన్వీనియన్స్ లెట్ ఏ మైనస్ డి ఏ ప్లస్ డి be the roots minus d, a plus d be the roots of the equation. ఎందుకు ఇలా తీసుకున్నాను? ఈ రెండింటికి డిఫరెన్స్ a minus d కి డిఫరెన్స్ ఏంటి? d. దీనికి డిఫరెన్స్ d. ఓకేనా? అంటే a plus d a plus 2d గా కాకుండా ఇలా తీసుకుంటే it is very easy to solve the it is very easy to find a and d values. సాల్వింగ్ లో మనకి ఈజీగా ఉండడం కోసం ఇలా తీసుకున్నాం. దేర్ ఇస్ నథింగ్ రాంగ్ హియర్. ఓకే, equation. Now the relations are, so what are the relations? So relations are annapudu s1 is equal to minus p1 adi. Okay, first one, what is the first relation? s1 is equal to minus p1. This implies s1 sum of s1 means sum of roots a minus d plus a plus a plus b. Alpha plus beta plus gamma is equal to minus p1. What is minus p1? This is p1. Okay, minus of minus 6 minus p1 p2 p3. Okay, na? This implies s1 is equal to minus p1. ఇక్కడ d cancel అయిపోయిందండి. 3a is equal to 6. This implies a is equal to 2. Okay, very simple. This type of problems we can solve easily. So see here, that is ఏం చేసాం? ఫస్ట్ గివెన్ ఈక్వేషన్ దీన్ని ఎప్పుడు కూడా మోనిక్ పాలినామియల్ గా రాసుకోవాలి. ఇలా రాసుకున్నాను. సో సిన్స్ గివెన్ దట్ ద రూట్స్ ఆర్ ఇన్ ఏపీ అన్నాడు కాబట్టి ఆ రూట్స్ ని ఏపీ అన్నప్పుడు మామూలుగా మీరు ఎలా అనుకుంటారు? ఏ ప్లస్ డి ఏ ప్లస్ 2d అని తీసుకోవచ్చు, అలా కూడా తీసుకోవచ్చు. బట్ ఇక్కడ ఏమైందంటే సి హియర్, నేను ఏ మైనస్ డి ఏ ప్లస్ డి ఈ ఫార్మాట్ లో తీసుకున్నాను 3 రూట్స్ ని. ఎందుకు? దే ఆర్ ఇన్ ఏపీ కాబట్టి. ఇలా తీసుకోవడం వల్ల మనకి ఇక్కడ s1 ఈజ్ ఈక్వల్ టు మైనస్ p1 రాయగానే మనకి d క్యాన్సిల్ అయిపోయి a వచ్చేసింది. ఓకేనా? సో మనకి రూట్స్ కావాలి అంటే ఏం కావాలి? వెన్ a అండ్ d తెలిసినప్పుడు ఈజీగా రూట్స్ రాసేయచ్చు. ఏది? a మైనస్ డి ఏ ప్లస్ డి రాసేస్తే రూట్స్ వచ్చేస్తాయి. సో ఇప్పుడు మనకి ఏ వచ్చేసింది. ఇంకేం కావాలి? డి కావాలి. అర్థమైందా? డి కావాలి. డి కావాలంటే నెక్స్ట్ రిలేషన్కి వెళ్తాను. అదే మీరు ఇక్కడ ఏ మైనస్ డి ఏ ప్లస్ డిగా కాకుండా ఏ ప్లస్ డి ఏ ప్లస్ 2d తీసుకున్నారనుకోండి, మీకు ఇక్కడ ఏ ఈజీగా రాదు. ఇక్కడ డి క్యాన్సిల్ అయిపోదు. అర్థమవుతుందా? ఏ 3a ప్లస్ 3dగా ఏ వస్తుంది. అర్థమైంది? ఓకే, now I go for the second relation. Second one, s2 is equal to p2. This implies what is s2? s2 means alpha beta. Okay, s2 a minus d into a plus a into a plus d plus s2 is equal to p2 అంటే s3 is equal to p3 ఎలా రాసినా కూడా అది వస్తుంది. సరే రాద్దాము. a plus b a minus b. ఓకే, is equal to p2 23/4 alpha beta plus beta gamma plus gamma alpha. A square minus AD plus A square plus AD plus A square plus D minus A square minus D square is equal to 23/4. A square plus A square plus A square 3A square minus D square is equal to 23/4. ఓకే నా? మనకి ఏం కావాలి? D కావాలి. వాట్ ఈస్ ఏ వాల్యూ మన దగ్గర ఉందండి? A is equal to 2 సబ్స్టిట్యూట్ చేద్దాం. సో 3 into A. వాట్ ఈస్ A? 2. ఓకే, 2 square minus D square is equal to 23 by 4. So this is 2 square, 4, 4 3 is 12. This implies, okay now, 12 minus 23 by 4. This is d square, okay now? This implies 48. So chasing 48 minus 23. How much? 25 by 4 is equal to d square. This implies d is equal to plus or minus 5 by 2. Plus or minus 5 by 2. So మీ ఇష్టం ప్లస్ ఆర్ మైనస్ 5 by 2 లో మనకి మన ఇష్టం ప్లస్ 5 by 2 తీసుకోవచ్చు. మనం ఎలా తీసుకున్నా కానీ మనకు రూట్స్ అవే వస్తాయి. నా మన దగ్గర ఏ ఉన్నది డి ఉంది. ఓకే, బోత్ ఏ అండ్ డి ఆర్ హియర్. సో యూ కెన్ రైట్ ద రూట్స్. సో ద రూట్స్ ఆర్ what is d is equal to 5 by 2 తీసుకుంటే a minus d అంటే ఇంత 2 minus 5 by 2. How much? That is minus 1 by 2. a అంటే 2. a plus d. 2 plus 5 by 2. How much? 9 by 2. Okay. So hence the roots are, what are the roots? A minus d, a plus d. A minus d, a plus d. Okay. So again I explain once again. See here. Solve the equation. Given that the roots are in AP. మనకు క్యూబిక్ ఈక్వేషన్ ఇచ్చారు. రూట్స్ ఆర్ ఇన్ AP అని చెప్పి ఒక చిన్న హింట్ ఇచ్చారు. Given equation is ఇలా రాసాము. సో ఐ మేక్ దిస్ యాజ్ ఏ మోనిక్ పాలినామియల్ ఈక్వేషన్ by dividing the with 4, the leading coefficient. Okay, you have to make this quotient as 1 always. Okay, before writing the relations between roots and coefficients. So ఇప్పుడు ఏపీలో ఉంటాయని అన్నారు కాబట్టి a minus d a plus d గా తీసుకున్నాను. సో కామన్ డిఫరెన్సెస్ ఏమి ఉన్నప్పుడు అవి ఆటోమేటిక్గా ఏపీలో ఉంటాయి. సో నౌ ద రిలేషన్స్ ఆర్ ఫస్ట్ వన్ s1 is equal to minus p1. ఇలా రాస్తే d టైమ్స్ అయిపోయి మనకి ఏ వాల్యూ వచ్చిందని. అండ్ కంప్లీట్ సెకండ్ రిలేషన్ s2 is equal to p2. ఓకే, s2 ఆల్ఫా బీటా ప్లస్ బీటా గామా ప్లస్ గామా ఆల్ఫా is equal to p2 is this one 23 by 4. So I am multiplying and simplifying, we got like this. And a మన దగ్గర ఉంది కాబట్టి a వాల్యూ ఇక్కడ సబ్స్టిట్యూట్ చేస్తే we got a d is equal to plus or minus 5 by 2. You can take plus 5 by 2 or minus 5 by 2. So the roots are a and d రెండు వచ్చాయి మనకి. ఇప్పుడు రూట్స్ రాసేస్తున్నాం. So we got the roots. That is our problem. Okay. Okay. I come to the second problem. Similarly, I have some other problem. ఇది ఇప్పుడు ఏపీలో when the roots are in AP అని చెప్పినప్పుడు ప్రాబ్లం చేశానండి. అలా కాకుండా సపోజ్ ద రూట్స్ ఆర్ ఇన్ జీపీ, అప్పుడు ఏం చేస్తాం? అప్పుడు ప్రాబ్లం చేస్తాను. Similar problems are there in your textbook. You can solve all those problems. That is minus 7, 14, minus 8. Okay. Solve the equation. Observe that equation. Solve the equation. This equation, given that the roots are in GP. Okay, GP, geometric progression. So progressions మీకు తెలుసు. AP, a plus d, a plus 2d and so on. That is AP, GP. AR square. So common ratio should be common in GP. Okay, so I am going to solve this problem. also very easy. So these problems are important for exam point of view. See here, given equation is x cube minus 7x square plus 14x minus 8 is equal to 0. This is a given equation. Okay. So since the roots are in GP, how can ఎలా తీసుకున్నాను ఇక్కడ మోనిక్ ఇది మోనిక్ polynomial equation. Here the quotient is already 1, so no need to divide by anything etc. Okay, this is our P1, P2, P3. Let A by R, A, comma AR be the roots of this equation. So why we are taking like this? Because the roots are in GP. GP లో టర్మ్స్ జనరల్ ఎలా ఉంటాయి చెప్పండి, AR స్క్వేర్ ఇలా GP ఉంటుంది. సో బట్ హియర్ ఐ ఆమ్ టేకింగ్ A by R. ఈ రెండింటికి కామన్ డిఫరెన్స్ తీసుకోండి. సో A by R, వాట్ విల్ గెట్ R. దీనికి రేషియో, ఓకే, నాట్ డిఫరెన్స్, రేషియో AR by A. ఓకే, లైక్ దట్. సో ఇంతకుముందు AP అన్నప్పుడు ఏం చేసాము, ఇన్స్టెడ్ ఆఫ్ టేకింగ్ A plus B, A plus 2D, we take A minus D, A plus D. Okay, for the sake of convenience. Okay, no doubt. A minus D, A plus B are in AP. Here also that A by R, comma A, comma AR, these three terms are in GP. Okay, because the ratio is same. So the idi by idi or idi by idi, just so we got the same ratio. Okay. So ఇలా తీసుకున్న తర్వాత now the relations ఇవి రూట్స్ అండి, దీనికి ఇక్కడ కోషన్స్ కనిపిస్తున్నాయి. Now the relations are first one, S1 is equal to minus P1. What is S1? Sum of R. Alpha plus beta plus gamma is equal to minus P1. P1 అంటే ఇదే కదండి, minus 7. This implies we can take here as 1 by R plus 1 plus R is equal to 17, 1 each. Okay, so ఇప్పుడు 2 equation 2, I don't want the equation 2, so you can take as 2 తీసుకోవచ్చు, లేకపోతే see here, next relation is actually S2 is equal to P2 రాయాలి. So I can write that or సరే రాద్దాము. What is the second relation? S2 is equal to P2. This implies S2 alpha beta. Okay, yeah, I think it is of no use. I write the third relation, that is S3 is equal to minus P3. So because of ఎందుకు తీసుకున్నా అంటే I will see here. So చూడండి S3, what is S3? Alpha beta gamma product A by R, AR, alpha beta gamma is equal to minus P3 is P1, P2, P3. What is minus P3 is minus C8, no doubt. So ఇక్కడ R cancel అయిపోతుంది. A cube is equal to 8. This implies A is equal to 2. Okay, so నేను ఈ థర్డ్ రిలేషన్ ఇది S2 is equal to P2 రాయకుండా దీనికి ఎందుకు వచ్చాను అని అంటే, so immediately we got A. Okay, if you substitute the value of A here, we get R. Okay, substitute అన్ని రిలేషన్స్ రాయాలనేవి రూల్ లేదండి, మనకు A is equal to 2 in 1. So 2 into 1 by r plus 1 plus r is equal to 7. This implies here when you LCM cheste 1 plus r square by r is equal to 7. This implies 2 plus 2r plus 2r square is equal to 7r. This r is in this side. This implies 2r square, 2r minus 7r minus 5r plus 2 is equal to 0. Okay? Go for factorization. So we got 2r minus 1, r minus 2 is equal to 0. 2r square minus 4r minus r. Okay, this implies r is equal to 1 by 2 or r is equal to 2. Okay. మీరు ఆర్ వాల్యూ ఏదైనా తీసుకోండి 1 by 2 or 2 ఏ తీసుకున్నా ఓకే. సో ఇప్పుడు మనకి ఏం వచ్చింది ఏ ఈజ్ ఈక్వల్ టు 2 ఉంది ఆర్ వాల్యూ యూ కెన్ టేక్ ఆర్ ఈజ్ ఈక్వల్ టు 2 or 1 by 2. We get the same roots. Hence the roots are a by r. A by r అంటే a ఫస్ట్ రూట్ అంటే a by r. a అంటే మనకి 2 వచ్చిందండి. వాట్ ఈస్ r? 2 అంటే 1. a is equal to 2. a అంటే 2, r అంటే 2. So hence what are the roots? A by r, a r. So what are the roots? That is 1, 2, 4 are the roots. Okay. So that is AB లో ఉన్నప్పుడు ఎలా చేయాలి, GP లో ఉన్న రెండు రూట్స్ అండ్ GP అప్పుడు ఎలా చేయాలి, రెండు మెథడ్స్ మీకు చూపించాను. అయితే AB అన్నప్పుడు A మైనస్ B A ప్లస్ Dగా తీసుకుంటాం. GP అన్నప్పుడు A బై R A ARగా రూట్స్ తీసుకుంటాం. So more and more similar problems are there in your textbook. You can solve all those problems.
Hello students, till now we have about capacitors and parallel plate capacitors and also series combination of capacitors, parallel combination of capacitors. Not only that, how much energy can a capacitor stores? So the energy stored in a capacitor is also very important. So our next topic is energy stored in a capacitor. Energy stored in a capacitor. For that, consider two conductors which are initially uncharged. After that, suppose some charge, if we consider some charge is transferred from second conductor to first conductor. Some positive charge is transferred from second conductor to first conductor. In a small installments, the charge will be transferred to first conductor. In a small amount of charge dq. Then what happens, automatically at a particular stage, conductor 1 will be at a higher potential and conductor 2 will be at a lower potential. Then the potential which it acquires, conductors, we have considered conductors 1 and 2. So positive charge is transferred from second conductor to first conductor. Then automatically the first conductor at a particular stage, the first conductor will be at a higher potential and the second conductor will be at a lower potential. Then a charge Q is, suppose a charge Q is there, then the potential which can acquired by that conductors. So the setup of these two conductors will combinedly gives it is a system of conductors. So this system combinedly is a capacitor. So in this capacitor, then the potential it acquired. The capacitor in which the potential it acquired. The potential where V is the potential acquired by that capacitor because of charge acquired by that capacitor. So where Q is the charge and C is the capacitance of that capacitor. And for this one, to bring positive charges from 2 and 1, to bring positive charges from 2 to 1, the external work should be required. So the small work in bringing the small charges from 2 to 1, we can given as this is the work done, the small work done in bringing positive charges from 2 to 1 will be given by the formula. We have a formula for the work done. dW is equals to V dot dq. As we have formula. Okay. So the small work done in bringing the charges in installments dq from 2 to 1, and it has gained some potential V dot dq. So dW is equals to V dot dq. So the total work we have to calculate in bringing the charges from 2 to 1, so that it is at higher potential and it is at lower potential Q. So it is at a higher potential which has acquired charge plus Q. So the total work we can calculate by integrating this equation. So dW is equals to, we have V is equals to Q by C dot dq. That is equals to, integrating both sides, we will get W is equals to integral Q by C. So from where to where? From Q is equals to, initially the charge, it is uncharged, from Q is equals to 0 to Q is equals to Q. As C is constant, the capacitance of that capacitor is constant. So W is equals to 1 by C integral Q, from Q is equals to 0 to Q is equals to Q. So that is equals to, we have integral Q is equals to Q square by 2 according to the formula. So that is equals to 1 by C into Q square by 2, from Q is equals to 0 to Q. So that is equals to that is equals to 1 by C into, we have to apply the limits, then we will get Q square by 2. So the final equation is, from this we will get W equals to 1 by C into Q square by 2. And also we can substitute the formula of the capacitance also. So this is the formula we have obtained for the total work done in bringing positive charge from second conductor to first conductor. W is equals to 1 by C into Q square by 2. And here the work done, what it is? It will be stored in the form of energy. It will be stored in the form of energy. So we can write the work done will be stored in the form of potential energy 1 by C into Q square by 2, or we can write 1 by 2 Q square by C. Also we have the equation for the capacitance. We have the equation Q is equals to Q is equals to C into V. So we can substitute that equation. Q is equals to C V. So by substituting this equation, we will get half into, from this equation, in place of C square V square, by substituting this equation in this equation, by C. C gets cancelled. So we will get half C V square. Half C V square. For this equation also we can write half C V into V. We can write it like this or not? C V into V. And already we have C V is equals to Q. So that is equals to half. In place of C, we can place Q or not? Q V. So totally we can write the equation forms like this. Half Q square by 2. Q square by C. That is equals to half CV square. That is equals to half Q into V. So these are the equations related to the energy stored in a capacitor. And also the energy which is stored in a capacitor will be resides in between these two plates. That means where in between the plates, what will it will have? It will have dielectric medium. So the potential energy will be stored in that dielectrics. Okay. So that is about energy stored in a capacitor. So the energy stored in the combination of capacitors while they are combined. So the total energy stored in the capacitors. The series combination already I told you, and the parallel combination also. In the series combination, the energy stored half Q square by C S, which is the resultant capacitance. So Q square by 2. So each one will have different capacitances. So 1 by C1 plus 1 by C2 plus 1 by C3 in series combination. The resultant capacitance is equals to 1 by C1 plus 1 by C2 plus 1 by C3. So if we have like this, Q square by 2 into 1 by C1 plus 1 by C2 plus 1 by C3 and so on for the capacitors which are combined. So if we multiply with this one, Q square by, again we will get 2C1 plus Q square by 2C2 and so on. So the total energy stored when it is combined in series is equals to, this will be equals to U1. The energy stored in the capacitor C1. And for the second capacitor, the energy stored is U2 and plus U3 and so on. And this is about the series combination. That means the total energy stored in the capacitors, combination of capacitors when combined in series combination will be equals to individual energies of the capacitors in the series combination. And for the parallel combination, if we take this formula, U is equals to half CV square. That is equals to half V square into half V square into, we have for the parallel combination, C is equals to C1 plus C2 plus so on. So C1, if we combine like this, half C1 V square plus half C2 V square plus so on. So that we will get for the capacitor, first capacitor C1, the total energy is U1, and for the second capacitor, the total energy is U2, and plus so on. So for the parallel combination of capacitors, the total energy is equals to the individual energies of the capacitors. So now either for the series combination or for the parallel combination. That means the combination is not important. Any of the combination, the total energy will be equals to the individual energies of the capacitors. Individual energies of the capacitors. This is about the energy stored in the combination of the capacitors. Energy density of the electric field. We have these equations. Now we have derived U is equals to half Q square by C. And also in the previous classes we have these equations. C is equals to epsilon naught into A by D, which is the equation for a parallel plate capacitor. Parallel plate. So the capacitance of a parallel plate capacitor, we have this equation epsilon naught into A by D, where epsilon naught is the electric permittivity and A is the area of the plates and D is the distance between the plates. And here surface charge density sigma is equals to Q by A, charge per unit area, charge per unit area. So that Q is equals to sigma into A. And also we have another equation, E is equals to sigma by epsilon naught. From these equations we can calculate the energy density of a electric field. U is equals to, from this equation, U is equals to half. In place of Q, we can place this equation or not. Sigma A whole square. So, sigma square by A square. And for C, we can place this equation by epsilon naught A by D. Okay, Q square by C. That is equals to 1 by 2 into sigma square into A square into D by epsilon naught into A. This A gets cancels. And now we have another equation which is for sigma is equals to E into epsilon naught. E into epsilon naught. So by substituting that equation also, we will get by substituting this equation. Okay, sigma in place of this one, we will have E square epsilon naught square. What is remaining? Into A into T by epsilon naught. And here the epsilon naught and this one cancels. And finally we got an equation half E square into epsilon naught into A into D, where this is the electric field intensity, epsilon naught is the permittivity of that medium, and between the plates of the parallel plate capacitor of a capacitor, area of the plates, A is the area of the plates and D is the distance between the plates. Area and distance, the product of the area and distance combinedly gives the volume of that capacitor between the which is present between the capacitor. So the energy per unit volume gives the energy per unit volume. This is the volume. So U by V equals to energy per unit volume gives half E square into epsilon naught. Half E square into epsilon naught, which is the energy density. The energy per unit volume gives the energy density of the parallel plate capacitor. Generally, we have already given the equation for the parallel plate capacitor, where C is equals to epsilon naught into A by D. So generally, not only for the parallel plate capacitors, we can have this equation for the capacitors too, for the energy density of the electric field, half E square into epsilon naught. U is equals to half E square epsilon naught. Sorry, small u, which is the symbol for the energy density, we can place U is equals to half E square into epsilon naught, where this is the energy per unit volume. So the energy per unit volume gives energy density of the electric field. Energy density of the electric field. This is the energy density. This is the energy density is equals to half E square into epsilon naught. Van de Graaff generator. Actually, students, this is not a generator actually. Van de Graaff generator. Actually, this is a particle accelerator. It is a particle accelerator. This is a particle accelerator. It is a particle accelerator, and also it is a machine that can build high voltages. The name is, it is a generator, but it is a particle accelerator. It can generate high voltages so that it can accelerate the charged particles. It can accelerate the charged particle. It can gives high voltages. That machine that can build high voltages. It builds high voltages. It can build high voltages, and also it accelerates. Used to accelerate charged particles. Accelerates charged particles. That means not neutral particles. Charged particles. And how the construction, actually the parts of this Van de Graaff generator are these. It contains a spraying tool which sprays the charges, and here it will have a pulley like this, in which this pulley is a motor driven pulley. This is a motor driven pulley, where by spraying the charges at this point, it can discharges the positive charges in this direction, and how it will be I explain. And this is the supporting column, and these are the grounded metal bases, and it will have an insulating belt. This is the insulating belt. Through that the discharge will happen, and also this is the collector core where the charges can be collected, so that the charges can be the high, because of building up of high voltage. Those charges which are collected here will be accelerated by using this Van de Graaff generator. And but actually it depends upon two principles. Those are, it depends upon two principles. One is action of sharp points or corona discharge, and second one is inside a conductor electric field is 0. Now let us see corona discharge. Actually we have the formula for the charges. We have the formula is, so the formulas are sigma is equals to charge per unit area. This is the surface charge density, and from this formula we can write for a sphere 4 pi r square. That means the radius. Here from this equation we can write this one is directly inversely proportional to the radius, and from here, from this equation we can write electric field intensity is directly proportional to surface charge density. So the surface charge density here is inversely proportional to the radius. So suppose for a conductor, if the conductor is like this, what happens for this? The radius here decreased. The radius here decreases gradually. So at these sharp points, the surface charge density will be very high. The surface charge density will be very high. Why? Because the surface charge density is inversely proportional to the radius. And here also the electric field intensity is directly proportional to the surface charge density. So here as the surface charge density is very high, electric field intensity is also very high. Here the total surface, and here the positive charges are here like this. Here more charges will reside. So at sharp points, as the radius decreases, more charges will reside. So what happens is, actually, if more charge is given, that means at very high electric field, if it is acquired very high electric field, this conductor, if it is acquired high electric field, then what happens is it can't bear anymore. That means if any positive charge is given to this conductor, what happens? It leaks. So the air which is present around this conductor, what happens? It polarizes this. If any more charge is given to this conductor, it polarizes the air. What happens? It polarizes the air. See, it polarizes. Suppose a conductor like this is there. Air molecules will present like this. So that no more charge can be given to this conductor. Then what happens is it ionizes. That means it polarizes the air molecule which are present around that conductor. So what happens? It attracts this negative charge towards this positive charge. Then what happens? The positive charges will remain here, which repels in the form of discharge. It will be there. In the form of discharge, it will be there. In which this phenomena which we are seeing in the form of lightning for the clouds. When the clouds will come near to a building or near to any large tree, then what happens is, in the form of discharge, this is nothing but the corona discharge, so that it can't bear any more the charge. So that what happens? It ionizes the air. Then what happens? At these points, at the sharp points, the leakage starts. So that it can attract the negative charge of the air molecule. So the positive charges which are present will discharge in the form of lightning, which happens for the lightning when clouds which are acquired with the charges, so many charges will discharges like that with a tall building or any other like that, because of ionization of air, which is called as corona discharge. Actually, the air is a dielectric. It is not a conducting one, but it can transform the electric effects. It is a dielectric, it can transform electric effects. So that effect in the form of corona discharge we can see for the lightning. So this on the basing of this principle, corona's discharge principle, the Van de Graaff generator works. So the second one is net electric field inside a conductor is zero. I already told you in the electrostatics of the conductors, inside a conductor, the electric field will be equals to 0 because of balancing on either sides of the conductor, so that the charges will reside on the surface only, on the surface, not inside the conductor. So the electric field inside the conductor is 0. So basing on these two principles, the Van de Graaff generator works actually. See, the insulating belt wound around the two pulleys. The insulating belt which is round the two pulleys at ground and the center of this spherical conducting shell. And also what happens is this belt continuously moves. This belt continuously moves by the motor which is at the lower pulley. By the motor which is at the lower pulley. And also at the lower pulley the charge is continuously sprayed. That means the positive charge will be sprayed onto it by the metal comb at the ground level. The charge is continuously sprayed. Spraying comb. By the spraying comb. The positive charges will be continuously sprayed by the spraying comb onto the metal comb, by the metal comb at the ground level, so that it carries to the top level. That means in this direction due to the corona discharge. Why? Because by continuously spraying the positive charge, what happens? Due to the leakage, then the positive charges will go in this direction due to the leakage, as it is the insulating belt, so that in that direction the positive charges will go through this and reaches here. And also next we will have the transfer of the positive charges to the another metal comb. Positive charges to the another metal comb which are connected to the large shell. Then what happens is the positive charge spreads uniformly to the outer surface. Due to corona discharge, one of the principle, due to corona discharge it reaches here, and the positive charge which is transformed will be uniformly spreads. Why? Because it uniformly spreads over the surface because of the second principle. Inside the conductor, the electric field, the net electric field will be equals to 0. So the positive charge will be uniformly spreads to the outer surface. So what happens automatically? So much of voltage difference will be there. Voltage difference will be there. So voltage difference is developed. So much of voltage difference is developed. That means about 6 to 8 millions of voltage difference is developed from the ground. It is actually built up so much of voltage difference, in which this voltage difference is helped in accelerating the charged particles. Will be helped in accelerating the charged particles. This will helps in the accelerating charged particles. This is how actually the Van de Graaff generator works. Students, these are all the topics related to this chapter. Once we will revise all these topics once, so that you can write the important points relating to these topics, and also the question and answers which comes related to these topics also we will discuss now. And also some more problems are also will be there in this chapter. And also mainly in this chapter we will have 1 2 marks question and 4 marks question for the IPA examination. 2 marks and 4 marks. So totally you will get 6 marks from this chapter. So very important topics in this chapter now we will discuss. And in the starting, totally this chapter depends upon bringing a positive charge in an electric field, bringing a positive charge in an electric field, so that for that one the external work is required. So basing on this, the total chapter is there we will have. And how the positive charges will be resides on the surface of a conductor, and also how the dielectrics behave, all these we have in this. In the starting we have about the electrostatic potential energy, and how the energy which is will be acquired by the positive charge. Will be acquired by the positive charge. In bringing a positive charge, some external work should be done. Some external work should be done. So that work which we have done will be stored in the form of the potential energy, which will be stored in the form of potential energy. So that energy in which the work done in bringing a unit positive charge. In bringing a unit positive charge is nothing but the electrostatic potential which will be present inside the conductor. So the symbol for which is given for the electrostatic potential is V is equals to work done in bringing a unit positive charge W by Q, or U by Q, in which this potential energy difference from maybe one point to another point, or from infinity to a point. If it is from infinity to a point, at that point only we can consider the electrostatic potential at a point. So the electrostatic potential due to a point charge. If we take the electrostatic potential due to a point charge, suppose a point charge is present here, then the electrostatic potential for if a test charge is there, then the electrostatic potential due to this positive charge at here we have calculated already, which we got is V is equals to Q by 4 pi epsilon naught into 1 by R. This is very important. This V is equals to Q by 4 pi epsilon naught into 1 by R, electrostatic potential due to a point charge. And also the equipotential surfaces are also very important. Equipotential surfaces, the points which are related to the equipotential surfaces are very, very important for you. Why? Because suppose for example the work done in bringing a positive charge from one point to another point on a equipotential surface, the work required is 0. Why? Because the potential from one point to another point on a surface is equal. So then if it is equal, so the work should be which is done should be equals to 0. So the points which are related to the equipotential surfaces are very, very important for us. And also the relation between electric field intensity and the potential is a very important relation, in which the equation is given by E is equals to minus dV by dr, which is also called as the potential gradient, in which the V is the potential and R is the distance or the radius we can take depending upon the situation, the example we have taken there. So and also the electrostatic potential can be measured in volts. And also the subunits also I already told you, the stat volt and also the subunits which are related to the volts I already told you. Joule per coulombs. Okay, the charge is in coulombs and the work is in joules, and the unit we can give is volts for the potential. And the questions related to these topics are, these are the questions related to those topics. Can there electrostatic potential at a point with zero electric intensity? The answer will be as the electrostatic potential at a point with zero electric intensity will be there. Inside a conductor, zero electric intensity will be there, but electrostatic potential will be present. So the answer for this question simply S actually. And for the explanation, why? Because inside a conductor the electrostatic potential will not be equals to 0, but the electric intensity is equals to 0. So for that one we will have 2 marks. This is a 2 marks question. And this one derive expression for the potential at a distance from point charge. Which we have the formula 1 by 4 pi epsilon is equals to 1 by 4 pi epsilon naught into Q by R, where Q, this is a constant, where Q is the charge of the charged particle and R is the distance between the test charge and the charged particle. V is equals to 1 by 4 pi epsilon naught into Q by R. So the derivation already I explained in the previous class, and the derivation is for 4 marks. Very important question. Derive expression for the potential at a distance from a point charge. And the derivations, in the case of derivations, you have to place the steps very carefully, and first we have to explain the diagram there. Diagram is very important. Simply line will be there, charge point charge will be there, that we have to indicate, and the indication of that test charge and the charged particle which is creating the electric field, that is very important. And the potential, V means potential, we have to indicate, and epsilon naught permittivity and 1 by 4 pi epsilon naught into Q by R. So for the derivation you will have 2 marks, and for the remaining explanation you will have 2 marks. So you have to place the steps carefully for this 4 marks question. And depending upon the equipotential surfaces, he asks a question, what are equipotential surfaces, that is for 2 marks. This one also a 2 marks question. And also the why electric field always at right angles at equipotential surfaces. Why electric field is always at right angles? Why? Because we have the equation dV is equals to E dot dr cos theta. From this equation, dV means the difference in the potential for the equipotential surfaces is 0. So automatically cos theta is equals to 0. Why? Because E electric field intensity and the distance is not equals to, and the radius is not equals to 0. So what is equals to 0? Cos theta is equals to 0. Electric field intensity is present, but for the equipotential surfaces the difference in the potentials is 0. So cos theta is equals to 0. So theta is equals to 90 degrees. So electric field is always at right angles to the equipotential surfaces, we can prove. So E and the potentials, the electric field is at right angles. So this is also a 2 marks question. Therefore simply 2 steps of derivation you have to place. For that one you will have 2 marks. And next the topics are the potential energy of a system of charges. For a system, the potential energy we have to calculate for the charges. We will get the formula U is equals to 1 by 4 pi epsilon naught into Q1 Q2 by R. Q1 Q2 by R. Where the potential energy in an external field. A potential energy in an external field means already we have not taken an external field, that means a source we have not considered actually. So when we are considering a source, the potential energy of that external field, that means when we place a point charge in an external field, then what is its potential energy? Then U is equals to V into Q at a distance R. We will have this formula for this one, and the potential energy of a dipole in an external field. For a dipole means it is a pair of opposite charge, equal and opposite charges, in which is separated by a distance, a very small distance. So such type of pair of charges is called as a dipole. Those charges will have equal and opposite charges. They will have equal charge, but opposite charges, they will be separated by a small distance. That is called a dipole. Until here we have calculated due to a positive test charge, or this one, like this test charge we have taken, or due to a positive charge the electric field is produced. For a positive charge the electric field is produced. For this one we have considered until this. For this topic we have considered a dipole, which is a pair of charges which are separated by a small distance 2a. So for this dipole, you will have another question. Another questions also related to this. When it is placed in an external field of a dipole in an external field. So for that one, the potential energy will be there. How that the questions related to these topics are. These are the questions related to those topics. Can there be an electric field intensity at a point with zero potential? With zero potential, can there be an electric field intensity? The answer is yes. There will be an electric field intensity with zero potential. For the dipole, I already explained you for the dipole for the equatorial line and also on the radial line. So you will have derivation for the radially, you will have one derivation for the dipole, derive an expression for potential energy of an electric dipole. Then you can prove that on the equatorial line of a dipole, on this line, equatorial line of a dipole, it will have zero potential. On radially, we can calculate the potential for that electric dipole, but equatorially it will have zero potential. This is for a 2 marks question. This one is a 2 marks question. And next question, you have derive an expression for the electrostatic potential energy of a system of 2-point charges, which we will get an equation. U is equals to 1 by 4 pi epsilon naught into Q1 Q2 by R. 1 by 4 pi epsilon naught into Q1 Q2 by R. And here we will have, don't confuse students, for the potential you will have one derivation, and for the potential energy you will have one derivation, and for the potential energy in case of an electric dipole also you will have a derivation. Mathematically you have to practice much for that derivations. So don't confuse for that one. And an expression for the potential energy for the dipole, and these two are the 4 marks questions you will have. These 4 marks questions are also very important for you, and this one is a 2 marks questions. And also the next topics are, students, electrostatics of conductors is a very, very important topic. In these you will have about 6 topics are there, including these electrostatics of conductor. Inside the conductor, inside conductor, net electric field is zero. That means the points which are related to this electrostatics of conductors will be applied in various situations of the charger of this electric field, electrostatic potential and capacitance. In this chapter we have to apply in so many situations. This electrostatic, this inside the conductor, the net electric field is zero, and also that means the electrostatic field is equals to 0 because of the balancing of the of the charges inside the conductor, which they will reside at the surface. So inside that conductor the electrostatic field is 0. The electrostatic field is 0. And another point is there, already I told you, now only at the surface of the charger conductor the electrostatic field must be normal to the surface at every point, at every surface of the point. I already told you it is normal to each other. Why? Because cos theta is equals to 90 degrees, I already told you. So E dot dr cos theta for the equipotential surfaces also this one, and also this that electric field intensity will be normal is at the surface of the charger conductor. The electrostatic field must be normal to the surface at every point. It will be normal to the surface at every point. At every point it must be tangential. And also the interior of the conductor will have no excess charge. In the static situation. Interior of conductor will have no excess charge. Interior of charge. No excess charge. In the static situation. In which situation? In static situation. And also the electrostatic potential will be constant throughout the volume of the conductor. The potential is constant. The potential is constant and has same value on its surface also. The potential is always constant. Already in the case of corona discharge also, the potential on the surface is constant. Or on the surface, the potential will be uniform. The potential is constant, but the electric field intensity changes. Intensity changes as the surface charge density changes. So the potential is constant. In the case of corona discharge at sharp points, what happens? The surface, even for the uneven surfaces also, the potential will be constant. And the electrostatic potential throughout the volume of the conductor will be constant throughout the volume of the conductor. And also we will have another important formula from we have the electric field. The electric field at the surface of the charged conductor, E is equals to, this formula we have to use in so many problems. So this formula is very important, which is from the topic electrostatics of conductors. E is equals to sigma by epsilon naught, where sigma is the surface charge density and epsilon naught is the permittivity of that medium or electric permittivity. And also next the topics we have about the dielectrics, and the dielectrics, how they are useful, I already told you. And those dielectrics, students, dielectrics and polarization is the next topic, which leads for the capacitors. We will have dielectrics and polarization is very important topic. And also there is some difference between the conductors and the insulators and dielectrics. Conductors are a different type of materials, and insulators are a different type of materials, and dielectrics are a different type of materials. Not like the insulators, they completely does not bond the charges. They will transform the electric effects. On applying the strong electric field, the electrics will transform the electric effects. So depending upon that small principle, the dielectrics are very useful for the construction of the capacitors. And what happens when the dielectrics are placed in the electric field? You will have one question also. The behavior of the dielectrics, behavior of dielectrics in an external electric field. External electric field. You will have one question related to this, 4 marks question. Very important. Behavior of the dielectrics in an external electric field. It is very important. And how the polarization, actually how the molecules will be distorted. That means there will be some changes in the shape of the molecules, which are it forms the dipole moment. Of course, for the polar molecules already dipole moment is there, but net dipole moment is equals to 0. So for the polar molecules, net dipole moment is equals to 0. After applying the electric field, the net dipole moment is not equals to 0. You have to write about that polar dipoles. And non-polar dipoles, the dipole moment is equals to 0. Actually, dipole moment is not at all for the non-polar molecules. So when the non-polar molecules, if they are placed in the external electric field, then they can produce dipole moment, and they can form dipoles, so that they can have dipole moment, so that the dielectrics, the behavior of the dielectrics can be explained behavior on the basis of behavior of the molecules when electric field is applied. You have to explain. You will have 4 marks question related to this question. Okay, in the next class I will explain you about the problems and also the capacitors and the questions related to the capacitors, and the problems are also there, very very important for this chapter. Okay students.